When talking about systems, we also have to talk about the difference between a closed system and an open system. A closed system is an isolated, self-contained system. It has no inner When looking at the physical structure of the Earth as a whole, let's take an overview of the Earth, and then let's dig deep and start to look at some of the main parts of the inside and crust of the Earth. We'll start at the atmosphere. We'll talk about that. Atmosphere is divided into layers. Let's look on the inside of the Earth. Outside of the Earth is considered to be the lithosphere. It's the crust of the Earth. Just below the crust is the asthenosphere. Just below the asthenosphere is the upper mantle, then the lower mantle, the outer core, and then the inner core. So the Earth is actually divided into layers based on chemical and physical properties. Now, we have not drilled down into the Earth. It's very important to understand that. Most of what we know about the inside of the Earth, we've gleaned from studying earthquake waves. The Earth is several thousand miles thick, and the deepest hole ever drilled is less than 20 miles into the Earth. But studying earthquake P and S waves tell us a lot about what's going on the inside of the Earth. If we look closer at the Earth and look at the inner core than the outer core, we think the inner core is a solid piece. We think there's a lot of metal in the inner core of the Earth. The outer core of the Earth we think is molten. We think there's still some residual heat on the outer core towards the inner side of the Earth left over from when the Earth was formed. That heat transfers to the Earth's surface through the mantle. If we look a little bit closer, we start to see that the Earth is quite dynamic. It's not just a static entity. It is actually somewhat moving and growing, melting, and sliding around on plates. Take a little bit closer look. We look at two important regions. The lithosphere, which is the very thin crust, the outer layer of the Earth, and the asthenosphere, which is just below the lithosphere. The asthenosphere we think is a plasticky layer that contains quite a bit of heat, but it does allow pieces of the crust to somewhat float on top of it and maybe move around on it. We do know that the crust is moving because we can see evidence of the crust moving in various ways. The crust is obviously where we live, and it's what we see as humans more often than not. There's actually two types of crust: the continental crust and oceanic crust. Oceanic crust lies under ocean. Continental crust is what we see and walk around on, and we call that land. Typically, continental crust is very thick. It's very buoyant. It's mostly the older form of crust. Oceanic crust is very thin. It's very dense, and it's more younger crust. When we talk about plate tectonics, we'll start to see that when these two pieces of crust meet each other, there's a lot of dynamics taking place.